Okay, so first of all, let's talk about arc length. And when we were doing parametric equations, we said arc length was the square root of dx dt squared. But now we're calling it dx d theta squared plus dy d theta squared, d theta. And we could do this because if we are dealing with polar functions, we know that x is r cosine theta and y is r sine theta. So if you have some r function, right, r is, I don't know, 1 plus cosine theta, right, then we can write x in terms of theta just by following this formula. But let's look at what we actually have here, because dx d theta, so dx d theta is going to be, I need to use a little product rule, derivative of the first times the second plus the first times the derivative of the second, and I know the derivative of cosine is negative sine. And then the same thing is true for dy d theta, derivative of the first times the second plus the first times the derivative of the second. And then we need to square these things, right? We need dx d theta squared. So let's just do that. This dx d theta squared is going to be, we're squaring that binomial, so it's going to be dr d theta quantity squared times cosine squared theta minus twice that product, 2 times dr d theta times r times cosine theta times sine theta plus the last thing squared, r squared sine squared theta. And dy d theta squared is going to do the same thing there. We're going to have dr d theta squared, but times sine squared theta, plus 2 dr d theta times r times cosine theta sine theta, plus r squared cosine squared theta. But you'll notice we need to add those two things together. So when I add these together, obviously those little terms drop out. And I am going to, out of these first two terms that I'm going to add together, I'm going to factor out the dr d theta squared, which will leave me with cosine squared plus sine squared. And for the last two terms, I'm going to factor out the r squared, and I'm again going to be left with sine squared plus cosine squared. So that our arc length formula, then, as somebody has found out, just simplifies into r squared plus dr d theta squared, d theta. And let's do one example using this formula. Not that it makes it that much easier, just saying. Let me go on to another page here. Okay, so what I'm going to do is I'm going to find the length of, let's say, r equals 1 plus sine theta. And we know what this is. We know that it's symmetric about the y-axis. We know it's a cardioid. And I know it takes us from 0 to 2 pi to complete this whole thing. And what I'm going to do is use a little symmetry. So I'm going to look at this from, let's say, negative pi over 2 to pi over 2. And that's going to give me that half of it. Okay, so we need dr d theta, which is going to be cosine theta, right? And we need r squared, which is going to be 1 plus 2 sine theta plus cosine squared theta. So when we look for our L, which I'm going to say is going to be 2 from negative pi over 2 to pi over 2, square root of dr d theta squared plus, oops, sorry, this is sine squared, plus r squared. I know I'm going to have 1 plus 2 sine theta plus 1, right, the cosine squared plus sine squared d theta. And let's see, we can take a square root of 2 out, because this is going to be 2, negative pi over 2 to pi over 2. I'm going to have the square root of 2 times 1 plus sine theta, d theta. And this becomes a little bit challenging, because I don't know how to do this. We can't use u substitution. Let's say I have 2 root 2, right? And I have root 1 plus sine theta. I think I'm going to multiply it by 1 in the form of 1 minus sine theta, so the square root of 1 minus sine theta, d theta, which is going to give me 2 root 2, negative pi over 2 to pi over 2. And in our numerator, we're going to have the square root of 1 minus sine squared, which we know is cosine squared, which is just going to give us cosine theta over root 1 minus sine theta, and there's the ticket, right? U is going to be equal to 1 minus sine theta. du is the derivative of sine is cosine, so that's going to give us negative cosine theta d theta. So, U substitution, we're going to have 2 root 2. The sine of negative pi over 2 is negative 1, so that's the opposite of negative 1, so that's a 1, right? And the sine of pi over 2 is 1, so this is going to give us 0. We're going to have negative. We're going to have u to the negative 1/2 du. I'm going to change this order, so we'll have 2 root 2 from 0 to 1, u to the negative 1/2 du, and that's going to give us 2 root 2, u to the 1/2 times 2. We're going from 0 to 1. It's going to give us 4 root 2 times 1. Okay, so then our total length, the circumference of this 1 plus sine theta, is 8 root